Okay, as we move on, we need to learn how to graph these inverse variation equations. And just so you know, my 3-year-old is right here.
What are you watching?
Helping. The easiest way to do this is to get a nice spread of points. You see Mommy's hand in the picture? Please don't touch my computer. So we're going to plug in -10, -8, -6, -4. We need a nice spread of points in order to actually get a good graph. And we're going to plug all of these numbers in for x. I know
Can you
usually...
put my hand on there?
Yeah, put your hand right here, babe. Say hi to the kids.
Hi, kids.
There you go. We need to put in a whole bunch of x's in order to get a good picture of the graph. Are you helping my kids learn? Yeah, okay. Now, Lily, tell them, what number is this right here? What number?
2.
It's a 2. That's correct. So what we need to do is we need to make a nice XY chart. Yes, they're all very excited to see your hand.
I want to have that.
You want my calculator back?
Yeah.
Okay, you're in a game somehow. There you go. All right, guys. So when you see this inverse variation equation, you need to pick...
I want that on there.
You want the calculator on here? Put it right here.
Right there.
The x's you need to pick are -10, -8, -6, -4, -2, 0, 2, 4, 6, 8, and 10. Now it's time to plug those numbers in. Can I see the calculator, please? Okay, I can do it in my head. So we're going to take these x's and put them in for right there. So we're going to do 2 divided by -10, and we get -0.2. And then we're going to do 2, thank you, divided by -8, and that would be -2.5, or 0.25, excuse me. Now we're going to do 2 divided by -6, and that's going to give you -0.3 repeating. And you can plug these in your calculator. Now we're going to do 2 divided by -4, that gives you -0.5. 2 divided by -2 equals -1.
Mom, we're going to play with my bubble gun.
You go play with your bubble gun. That's awesome. Now we'll do 2 divided by 0. Now when you do 2 divided by 0, you're going to get an error because you can't divide by 0. So what we're going to write is undefined. Okay? Now we're going to plug in +2. 2 divided by +2. And we'll get +1. Then 2 divided by +4. We'll get 0.5. Then 2 divided by 6. We'll get +0.3 repeating. 2 divided by +8. We'll get +0.25. And 2 divided by 10. We'll get +0.2. Now I did that really fast, so if the substitute would, probably be a good idea for you to pause the video here, let the students grab all of those points, and then push play when everybody's ready to graph. All right, we are going to plot these points. Notice we're skipping by 2's, so -10 and -0.2 is super, super, super tiny right there. -8 is also super, super, super tiny right there. -6 is also very tiny. It's like right there. They're starting to go down. Let's see, -4 and -0.5. That's easier to plot at least. -2 goes to -1. Okay, so what you need to be able to see, let's see this, is that this graph, and you know what we really probably should have done? We probably should have plugged in -1 as well, because my graph isn't really coming together so great. So let me encourage you to extend your XY chart here so we can see what -1 looks like. So if I plug in -1, I get 2 over -1 equals -2. There we go. So here's my -1, here's -2. Now we can actually see what's happening. And if you want to plug in more points, you're more than welcome. But here's what's going to happen. You're going to get this kind of a graph. It's going to approach both axes, but never cross over. Now, when you plot the positive side, the same thing's going to happen. Let me actually get +1 up here, though, so we can see what +1 looks like. So 2 over positive 1 is actually going to make a 2. So let's plot all of our, remember 0, we're not going to have anything on 0. It's never going to touch the y-axis. Okay? Let's plot these. So go over 2 and up 1. Go over 4 and up 0.5. Look how tiny these are again. And then when you plug in 8 and 10, you get even smaller values. So again, we have this nice like weird curve going on. And remember when we plugged in 1, let's see, we got 2. So that's going to be here. So again, you can see this kind of like turn that's happening. It's going to approach the y-axis, but never touch the y-axis. So I want you to do that here and here too. This is what all inverse equations look like. You see this right here, this vertical line I'm drawing? It should never touch that vertical line. Now we're going to do that again, but may I please encourage the sub to pause the video here. We're going to plug in the same numbers, guys. Maybe we'll even plug in 1 and -1 this time. So -10, -8, -6, -4, -2. Let's plug in -1, even though we didn't last time. 0, 1, 2, 4, 6, 8, and 10. If the substitute could please pause the video, have all the students plug in these numbers and get values out, I'm going to pause my video and put the answers in, so when you play it, all you need to do is check it. If everybody could check and make sure that you got these y values out, that would be wonderful. And pause the video, if you didn't, to double check and ask questions as to why you got them wrong. It's now time to plot our points. So we're going to go -10 and up 0.8. Notice this one is negative, so like our graph, instead of looking like this, it's going to look like, it's going to be on these two corners. Okay, -8 and 1. -6 and 1.3. -4 and 2. -2 and 4. You can see this one's increasing a lot faster because we had a -8 on the top instead of just a 2. -1 and 8. So there we go. We're getting a lot better of a graph this time, and you can see that shape starting to happen. So let's go ahead and connect. Remember, it's going to approach the y-axis and the x-axis, but it's never going to touch them. Going to start leveling out almost. Plot your other points. It's going to be in this quadrant over here. 0, there's no point. That's your undefined. So 1 and -8. 2 and -4. And if people are struggling, I'm asking the substitute to pause the video and help them be able to graph, please. Let's see, where was I at? So I did 4, -2, 6, -1.3. -1. And you can see the exact same, like, inverse shape happening on the other side. Definitely not a straight line. There you go. And this is how all inverse functions will look like. You just had to make sure you pick the right x's to plug in. All right, let's try this. Again, you're going to love this. Okay, time to figure out in this particular lesson if it is linear, which you studied in chapter 5, if it's a straight line or if it's direct, or if it's inverse, which you're studying right now. Now, to test for direct variation, you know what, can we erase the word linear? And instead of writing the word linear, I actually want you to write the word direct. Because sometimes it is direct variation. P.S. That is a type of linear. It is linear, but it's a specific type of linear. It's called direct variation. So to test for direct, you need to do the first thing we need to remember is that the equation is y equals k times x. Okay, this is the equation. Okay? In order to test for direct, you actually need to take all of your y's and divide them by all of your x's and see if you get the same thing each time. If you do get the same thing each time, you have found k. And so y equals k, whatever you got, times x. Now the equation, when we go to inverse, the equation is y equals k over x. Remember, this is the equation. But in order to figure out if it fits the equation, here's what you need to do. You actually need to do y times x. It's almost opposite of what you want to think, isn't it? Like to test for a division problem, you have to multiply it. And to test for a multiplying problem, you have to divide it. So just remember, it's like opposite of what you want to actually probably do. If y times x is the same each time, you found it. So your equation would be y equals k, whatever you get, divided by x. Let's test this out. And they have the graphs of each. This is the direct. This is from chapter 5 when you were with Miss Shirey or Mr. McBurney. Just a straight line through the origin. In fact, why don't we put that on there? See how it's a straight line through the origin. And here's inverse. This is what you're learning right now in chapter 11. It's those funny graphs we just did on the previous page. Okay. Do the data in each table represent direct or inverse variation? For each table, write an equation to model the data. So when I look at this, I'm going to notice that this side's getting bigger and this side's getting smaller. Can you see that how this one's going, x is getting bigger, but y is getting smaller? I am going to test inverse. Now, if you didn't notice that's okay. I just know that quick little shortcut. So to test for inverse, I'm going to write inverse test. We are going to do every y times every x. So I'm going to do 20 times 2. I'm going to do 8 times 5. I'm going to do 4 times 10. What do you notice each and every time I get? Every single time I get 40. That means it is inverse. And now if you tested direct, it would not work. So what we write is y equals, you have found k, 40 over x. There's the equation they want. Part B. Oh good, now my cat's on the table. You guys are just meeting my whole family. I'm going to look at this. We have 3, 6, 12. I am noticing, hi, kitty cat, please, oh my. I bet you guys are enjoying this, them actually being there, aren't you? So 3, 6, 12. I notice as x goes up, 24, I'm noticing that y goes up. Well, that was direct variation back in the day. So we're going to test for direct. Well, the test for direct, you actually take all your y's and you divide by all of your x's. Kind of weird, but it is true. So I'm going to do 24 divided by 3. I'm going to do 48 divided by 6. I'm going to do 96 divided by 12. And I'm going to hope that I get the same thing each time. And look at that. Every single time I get an 8. So I know that this is true. So my equation for direct is y equals my k value, not divided by x, times x. And you all, of course, remembered that from when you were with Miss Shirey and Mr. McBurney. They'd be so very proud of you. Wow, there's a lot of problems today. Okay, problem 4. Does the data represent direct or inverse? So, okay, there, I thought the video paused or stopped. We're going to do this again. So I am noticing that these numbers are going up and these numbers are also getting bigger. I know that kind of looks funny because they're actually getting smaller because of the negatives, but the value of the numbers themselves are getting bigger. I'm going to try testing for direct to see if it works. Okay, so I'll write direct test. So to test for direct, I wrote on the previous page, you do y divided by x. Let's do this. Negative 12 divided by 4. Negative 18 divided by 6. Negative 24 divided by 8. What do we get every single time? Negative 3. That means, yep, it is direct. So here's what we do. We make our equation. Y equals, direct is the k value, that's the k value, times x. Pretty easy, right? Now remember, it's my job to make this look easy. Now x's right here in part B, I notice, yep, they're getting bigger. And my y values, like, not the negative part, but like the actual numbers themselves, I see that they're getting smaller. So to me, that means, hey, why don't you test for inverse? And if you're wrong, why don't you go back and see if it's direct? Let's do an inverse test. So that would be y times x. So I do negative 12 times 4, negative 8 times 6, negative 6 times 8, and negative 48 each time. Because every single time it's negative 48, I know that I am correct. So my equation will be y equals the k value divided by x. Even though the test was multiply, the equation is divide. Problem 5. Direct or inverse again, explain. It costs $25 every day you have a rental car. So I want you to compare how many days you have the rental car and the total cost. Well, to me, as the days go up, what happens to the cost? The cost goes up. That is direct. And I don't think we need an equation. So our explanation is right here. As one goes up, the other goes up. That's my explanation, real fancy. Part B. Several runners compete in a 200-meter run. So we've got people running. Their time, how long it takes them, and their speed. Let's see. Well, to me, the longer it takes somebody like me, because I hate running, the longer it takes somebody, that means the slower that person goes. And that is 100% true. I only run if I'm being chased. Okay? So as the time goes up, that would be me. And the reason that happens is because I am slow. My speed is going down. Okay? And the vice versa happens too. Like the faster you are, the less time it's going to take. So that would be inverse variation. I like these ones. Okay. Again, you buy sweaters in a clothing store. $35, that's really expensive. Don't buy sweaters for $35. How many you buy, I don't know, maybe you want to spend your money there. Do whatever you want with your money. No, don't do whatever you want. Okay, how many you buy and how much you have to spend. Okay, as the number of sweaters you buy go up, the total cost goes up. This is direct variation. See everything. My video kept freezing, so I have no idea how much of that you actually got. But as the number you buy go up, the total cost goes up, which makes that direct. Part B. You walk 5 miles each day. I don't have time to walk 5 miles each day. I hope you guys do. Your speed and the time spent walking. Well, this is the same as that last problem. As your speed goes up on that walk, the time you spend walking, that goes down. Because like if you run, obviously your speed is going to go faster and you're going to get home faster. Or so your time is going down at the time that it takes. So that is inverse. And that is the lesson in a nutshell. I hope you enjoyed inverse variation. Just remember, inverse means as one goes up, the other goes down, which is why we have that goofy looking graph. And I think that's it. I hope you guys do a good job making your equations. Good luck.